All right, honors geometry. So, welcome back. Part two of the notes here. Proving what shape or what parallelogram, which type of parallelogram we're dealing with on the coordinate plane. We're going to start off. We have to establish that the quadrilateral is a parallelogram. Now, this is a review from what we did, before all this started. So, to prove that a quadrilateral is a parallelogram, we can choose one of these three options. Remember, you don't have to do more than one. You only have to do one of them. So, keep that in mind before you look at number 11. All right, so we can prove that opposite sides are parallel using the slope formula, just confirming that opposite sides have the same slope. Another way, we could prove that opposite sides are congruent by proving that they have the same distance. You guessed it, using the distance formula. And then the third way, and probably the quickest way, but remember, options 1 and 2, these could actually help you later on if you happen to get that information, so keep that in mind. But option 3 would be proving that the diagonals bisect each other, so basically just confirm that the diagonals have the same midpoint. It means that point would be on both diagonals. That's where they meet, so they're cutting each other in half. So if you prove any one of those three options, you have a parallelogram. Now, step 2 is going to be to prove whether the parallelogram is a rectangle and or a rhombus. It could be both, which, you'll see in a second that would make a square. So with rectangles, we could prove that all angles are right by proving that consecutive sides are perpendicular using the slope formula. Now, if on step 1, if you use the slope formula on the sides, you already have that information, so you don't have to crunch it again. You can just confirm, okay, are the consecutive sides... are their slopes opposite reciprocals? Now, your other option would be proving that the diagonals are congruent. Now, nothing you do during step 1 is going to help you here. You just have to run the distance formula on each diagonal and see if they're congruent. So if you can prove either one of those two options, you have a rectangle. Now for rhombus, option 1 would be to prove that all four sides are congruent. So if you happen to use the distance formula on step 1, again, you would already have this information. So just confirm that all four sides have the same distance, and you're good to go there. Now option 2 would be to prove that the diagonals are perpendicular using the slope formula. Now nothing from step 1 is going to help you there. You just take the slope of each diagonal and see if they're opposite reciprocals. So if either of those are true, you have a rhombus. Remember, you only have to do one of the two options on each of these. All right, now step 3, if you can prove both a rectangle and a rhombus property, then you have a square. If anything goes wrong above, you cannot have a square. Now, guys, it's important when you show your work that you show all slopes, midpoints, and distances that you find and label them. Try to make it easy for me to follow. Now, on number 11, on page 11, I literally did all the work possible just so I can kind of show you guys every single way you could go about doing it. On pages, 12 and 13, I'm actually going to show you guys a couple of, methods that I think are a quick way to go about doing this. And there are more, but these are what I've found have been the easiest for, high school students to remember. All right. So important formulas up top on page 11. We got the slope formula, y2 minus y1 over x2 minus x1. We got the distance formula. We're taking the square root of x2 minus x1 squared plus y2 minus y1 squared. And then finally, we got the midpoint formula where we have 2 points. We add the x coordinates together, divide them by 2. Add the y coordinates together, divide those by 2. And we have the midpoint. All right, so... taking a look at some of the information. So I showed you guys how to get the slope of each side. So KL and JM are both negative 2 over 9. KJ and LM are both 6 over 7. So we do have a parallelogram based on that information. Now another way we could have figured out if it's a parallelogram is by taking the distance of each side, and as you can see, opposite sides are congruent here. In fact, all four sides end up being the square root of 85. Now the last way we could have proven that it's a parallelogram would have been to use the midpoint of the diagonals, and you should get 1, 0 for both of those midpoints, so they do bisect each other. All right, so those would be your three options for parallelogram. Again, you only have to do one of those ways. Now for rectangle, we're trying to see if either the diagonals are congruent or the consecutive sides are perpendicular. So if we had used the slope formula for parallelograms, we'd be able to look at that and, -2/9 and 6/7, those are not opposite reciprocals. So K, L, M, and J, none of those are right angles, so it cannot be a rectangle. Another way you could have done it is if you had, taken the distance of the two diagonals, you would find out that KM is the square root of 68, JL is much bigger, the square root of 272. So they're not congruent. We don't have a rectangle. Now, rhombus, there's two ways to prove that it's a rhombus. If we had done the distance formula for parallelograms, we would have confirmed that all four sides are the square root of 85, and we would have known it was a rhombus by doing all that work as well. The other method we could have used is finding the slope of the diagonals, and we have -4 for KM, we have 1/4 for JL, so those are opposite reciprocals of each other. So we do have a rhombus. Now finally, when we get to square, it's not a square because it is not a rectangle. It did not pass that test. So again, you only needed to establish one of these, but it's a parallelogram because opposite sides are parallel and congruent, and the diagonals bisect. It is not a rectangle because consecutive sides are not perpendicular, so no right angles, and the diagonals are not congruent. It is a rhombus because all four sides are congruent and the diagonals are perpendicular. And finally, it is not a square because it's not a rectangle. It has to be all of the above to be a square. All right, so now on to what I think are a couple good methods to go about doing this. Geometry students, a lot of you guys hate the distance formula for whatever reason. I mean, I guess it's a little bit more involved than the other two, but if you've been awake in class, we've talked about my Taco Bell analogy where, it has the same ingredients as, the slope and distance formula have the same ingredients, just different ways of presenting them. They both have x2 minus x1. They both have y2 minus y1. So everything on the menu, same ingredients, different result. Anyways, for you slope people, here's a slope method. Now you could do something like this with the distance formula too, if you really like that. But just from polling you guys all year, I know that a lot of you guys just like the slope formula. All right, so on the sides, I took the slope of all four sides, A, B, and DC. Ended up being -2, so we got a pair of opposite sides parallel there, and then AD and BC ended up being +1/2, so again, we have opposite sides are parallel. So, parallelogram, yes, opposite sides are parallel. Now, when it comes to rectangle, we can continue with this information, so we did all this work, why not use it for more? So if we look at -2 for AB, now AD, so AB and AD are a pair of consecutive sides. So if those slopes are opposite reciprocal, that would tell me that angle A is a right angle, and then we know it's a rectangle. So looking at, AB with a slope of -2, if we flip that upside down and change the sign, that would be +1/2, +1/2. So AD is perpendicular to AB. Angle A is a right angle. And, the other consecutive sides all check out too. So rectangle, yes, consecutive sides are perpendicular. So we took the slope of all four sides and we were able to, diagnose whether it's a parallelogram and whether it's a rectangle based on that work. Now, I called it the slope method for a reason. We're going to keep using the slope formula now with the diagonals. So AC has a slope of 7/4, BD has a slope of -1/8. So those are, if this was a rhombus, we would need those to be opposite reciprocals of each other. We would need them to be perpendicular. That is not the case, so it failed the rhombus test. So rhombus, no, diagonals are not perpendicular. So looking at the breakdown here, it is not a square either because it's not a rhombus. It has to be all of the above. So that's how that one works out. So, just to recap, we ran the slope formula 6 times on this problem on all four sides and the two diagonals, and that was enough information to break down what type of parallelogram the shape is, or what type of quadrilateral. All right, looking at the next page. Now, this one I think is kind of an easy one to remember as well because we're working with the diagonals. So it is the diagonals method, and in this, just like the last one I showed you with the slope method, we're going to be crunching 6 different formulas. We're going to take the diagonals, and we're actually going to put them through all 3 formulas. We're going to take the midpoint of both diagonals, we're going to take the slope of both diagonals, and we're going to take the distance of both diagonals. So we start with the midpoint. So the midpoint of AC and BD, both of them have 1/2 for their x-coordinate. Both of them have 7/2 for their y-coordinate. So the diagonals do bisect. So based on that, we know it's a parallelogram. Yes, the diagonals bisect each other. Now from there, if we're going after the rectangle, we're going to take the distance of the diagonals now. So we're just taking those diagonals and running them through each formula that we're working with here. So the distance of AC is the square root of 58. The distance of BD is the square root of 58. So the diagonals are congruent. So yes, it is a rectangle. It passes that test. Next, we're going to look at the slope. So we're on to the last two little equations here. We're running the diagonals both through the slope formula. AC has a slope of -3/7. BD has a slope of 7/3. Those are opposite reciprocals of each other. Flip them upside down and change the sign, and they would be equal to each other. So the diagonals are perpendicular, which means yes for a rhombus. So if it's yes to all three of these shapes, hopefully you guys know by now what that means. That means yes, it is a square. So it satisfies all conditions above. So just to recap the diagonals method, you're going to take the pair of diagonals and run them through the midpoint, distance, and slope formulas, and then that will be enough information to, classify this shape or properly name that shape. So we have a square here. So if it's all of the above, square is the most precise name we could give to this. All right, looking at the rest of the way, we're on to trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Now I want to clarify, some definitions you'll see will say at least one pair of parallel sides, so it really depends on your source here, but we're going to go with exactly one pair of parallel sides just to kind of separate it from that parallelogram family. So parts of a trapezoid, we have the bases. Those are the parallel sides of the trapezoid, so that's A, B, and DC here. The legs are the non-parallel sides, so here that would be AD and BC. As you can see, if they continued, they would end up intersecting each other. They are not parallel. Now the base angles, each trapezoid is going to have two pairs of base angles. So they are the two vertices, plural of vertex. So they're the two vertices that are connected by a base. So if we look at AB as a base, that means angle A and angle B are going to be a pair of base angles. If we look at DC, the other base, that means angle D and angle C are going to be the other pair of base angles. Now, these angles are congruent if we're talking about an isosceles trapezoid. So if this was an isosceles trapezoid, angle A would be congruent to angle B, angle D would be congruent to angle C. So properties of isosceles trapezoids, let's go over those real quick. We got one pair of opposite parallel sides, and that is the bases. We have one pair of congruent legs. We have two pairs of congruent base angles like we talked about. The diagonals will be congruent. If we had drawn them in, AC and BD would be congruent. And then the two angles connected by a leg are supplementary. So angle A plus angle D would be equal to 180. And remember back with the angle relationships, if we know that we have a parallel side here, we have a little transversal intersecting those two parallel sides. So angle A and angle D, anybody remember what type of angle relationship they would have? So again, I'm doing that little Sesame Street pause there for you guys. So angle A and angle D would actually be same side interior angles. So they're going to be supplementary. Same side, supplementary. And then angle B and angle C are also going to be supplementary. They would be same side interior angles as well. Yes, BC would be the transversal in that case. Now, ways to prove that a trapezoid is isosceles in the coordinate plane. We have to start with step one, where we would use the slope formula to prove that one pair of opposite sides is parallel. So if the first pair you pick isn't parallel, just make sure you double check the other pair to confirm that we're even dealing with a trapezoid at all. If both pairs of opposite sides fail, it's not a trapezoid. Then after that, once we figure out that one pair of opposite sides is parallel, we're going to take the other pair of opposite sides and use the distance formula to prove that they're congruent. If they